We checked all 4 systems, and you were go on modulation, all 4, and keying was a go.
Roger, you're loud and clear here also.
With stars and weightlessness for company, we, the astronauts of the International Space Station, live 400 kilometers above the Earth, clinging to the void of space. A void in which, more and more frequently, a new type of danger appears, which is a problem for all of us. Consequently, it is a void under strict surveillance. And on the 27th of October 2014, the watchful engineers were worried. Something was approaching the station. Much too quickly, much too close. Debris. The engineer's nightmare. If it hits us, we're finished. On Earth too, debris threatens our way of life. My name's Thomas Pesquet, I'm an astronaut. I'm in training for a mission, 6 months in the International Space Station. I think future space conquest is very important for everyone. The further we look into space, the more we look at our past, and it's clear that a planet like Mars is where our future lies. We're advancing in an environment which is difficult, and we're advancing quickly, but it's an incredible journey. Let's pursue this adventure together, and I promise you, you won't be disappointed. Human activity in space has produced technological marvels. The only blot on the space landscape is the pollution which it has generated. And the offspring of this pollution is millions of pieces of debris, including this one, calmly cruising along at 28,000 kilometers an hour. In its direct sightline, the ISS, the International Space Station. During my training, I had to learn how to handle catastrophe scenarios, which is where I discovered the new threat of space debris. There are 3 main emergency categories on board the ISS. The first is fire. The second will be toxic materials spreading through the station's atmosphere. The third is depressurization. And one of the possible, even probable causes of that would be debris. A hole in the outer shell causing our atmosphere to spill out into the void of space, which would clearly be life-threatening. But we have our guardian angels. They are down below in Houston, in the United States. They are the NASA engineers who, along with the Russians, deal with the day-to-day running of the ISS. And consequently, on the 27th of October 2014, their absolute priority was to modify the station's orbit. Debris in sight. Modifying the orbit of the ISS is not an easy maneuver. For example, if anyone is engaged in extravehicular activity, you can't start maneuvering the station, it would be too dangerous, so it's not something to be undertaken lightly. On this particular day, there was no one outside, so the station could be maneuvered. But there was a sizable problem.
When there is a clear risk of collision with the space station, it takes about 24 hours preparation before moving it. All the experiments have to be stopped, special positions have to be taken up, the motors have to be preheated, etc., etc. So when the station has time to move, it can move.
But on this particular day, time was not something the station had.
A warning came through that a certain amount of debris was heading for the station, information which arrived very, very late. So rapidly, in less than an hour, teams were put in place at the control center.
The engineers went back over all the calculations, but the results were indisputable. They had 6 hours ahead of them. Only 6 hours before the debris came within 10 kilometers of the station, perhaps 5 kilometers, perhaps even less. The calculations were not precise. How could they be when faced with an uncontrollable object? The station had to be moved as quickly as possible.
Port starboard in front of the vehicle.
Perhaps the solution lay here.
À 12 de DDO, attention pour moins 1 minute.
In this Ariane rocket. It had taken off 2 months earlier from the Guyana Space Center at Kourou. Its mission, to carry into space a module which after a 5-day journey had successfully docked with the ISS. It's called an ATV, an automated transfer vehicle. And on that day, all attention turned towards it.
L'ATV, c'est un cargo donc de ravitaillement.
An ATV is a supply vessel for the space station, used to carry freight, equipment, food, etc.
Mais il sert aussi.
But also used to collect all sorts of refuse and waste matter which builds up on board the station.
The ATV, specially built for the European Space Agency, has a significant ace up its sleeve. It is fitted with powerful motors, much more powerful and reactive than those of the ISS itself. And on that day, these motors qualified it for an emergency mission, that of Space Tow Truck. And this is the mission which was undertaken by the ATV engineers, based at the CNES in Toulouse, with a green light from Houston and Moscow.
The motors of the ATV, which was attached to the station, were started up to attempt an orbit reboost in order to avoid the debris which was heading towards the space station.
It's basically a question of accelerating and pushing the station's orbit upwards. We don't bring it downwards because that would use fuel just to use more fuel later to take it back up, whereas it tends to descend on its own. So what we often do is move it up. Slowly but surely, the ATV towed the station 4 kilometers vertically upwards.
The station weighs about 400 tons, and a push of half a meter per second lasts about 10 seconds. So that's in the region of a couple of kilometers an hour, which is relatively slow and hardly appreciable from inside the station. The astronauts may notice a few objects moving around, but they don't really feel it.
And you can see, and we get moved. The space station's accelerating, leaving us behind.
So each time the ATV gives a push, the crew just has to follow the movement.
Wow.
On this occasion, they were able to carry on calmly with their work while we were doing the job which needed to be done.
The danger was avoided. On this occasion.
Slightly less than a month later, we had another piece of debris which obliged us to make the same sort of emergency maneuver.
Today, the ISS avoids debris 4 or 5 times a year.
It's definitely a growing risk, which represents a serious problem on a security level for spacecraft in those orbits.
In 1957, the Russians got off to a flying start. Sputnik was the first object in the world to be launched into space, and the first future debris. The reply from the Americans was immediate. The space race was on. Americans, Russians, Chinese, Europeans, all jostling for the lead in know-how and creativity. And the result? More than 6,000 launches to this day. Rockets, satellites, probes, space shuttles, orbital stations. Over tens of years, 20,000 tons of material have left to join the stars, without anyone actually realizing that these gems of technology are hurtling towards their future destiny as space debris.
Space or orbital debris are artificial objects which have no function and therefore no use. A typical example would be a satellite, which after good and faithful service has broken down and died and been left up there. That's debris.
Everything which was used to launch the space object is abandoned. 29,000 objects of between 10 centimeters and several meters in length are thus left to wander above the Earth. But debris can also come from the everyday workings of a space mission.
Is that right?
Because man, on Earth as in space, generates pollution. Debris is also made up of cables, straps, lens covers, springs, explosive bolts, or even tools used during an outing are not always caught hold of.
We lucked out in that we demonstrated this use.
Or which unfortunately slip through the fingers.
Yeah, we see him.
Everything's clear.
Sometimes objects are even purposely thrown overboard, like this vat of ammonia, which the engineers no longer consider useful for the ISS.
Go on the ground. So when you're ready, you can practice the techniques that you practiced and give it a go.
All right. I'm leaning back right now. Or at least I think I am. All right. And I'm going to start rocking forward. Patience. Jettison. Put yourself.
And thus, in 2007, half a ton went out into the void.
And it's
That was before the Great Realization. It was also before it was understood that of all debris, the most problematic is perhaps the dead satellites, which still contain fuel. Fuel which the engineers call propellant.
Once a mission is over, there's always an amount of propellant left inside, combustible fuel trapped behind closed valves. So if it gets heated up by the sun because there's a fault in the thermic protection, and as a result the propellant vaporizes, it can cause a pressure cooker effect and...
The explosion generates a spray of new debris. Debris which is even more dangerous. Because, contrary to the 27,000 large objects, these ones are too small to be effectively followed by radar, and therefore difficult to catalogue or keep under close surveillance.
Instead, about 6.5 minutes after we deployed it, it exploded, and this was the fragment that we wound up tracking with the radar out to some 50,000 feet.
Concerning small debris over 1 centimeter, we're looking at several hundreds of thousands of pieces. No one has counted them. The big objects have been counted, and we know where they are on a day-to-day basis. The others haven't been counted. But we are talking about very significant numbers.
There are perhaps 720,000 pieces of debris of between 1 and 10 centimeters roaming around above our heads, some of which are everlasting enemies. Their lifespan depends upon their altitude, but is often linked to the infinite scale of space.
At an altitude of 200 kilometers, their lifespan is perhaps 3 or 4 months. When they're at an altitude in the region of 400 kilometers, you start talking in terms of years. For example, at an altitude of 800 kilometers, we estimate that for a normal satellite, the lifespan is 2 centuries. When you're at 1,000 kilometers, it's between 1,000 and 2,000 years, and beyond that, it's even longer.
That gives them plenty of time to crash into each other, thereby producing more debris, which produces more, which produces still more. I have to say it's a bit embarrassing. It's an environment where there was nothing. which was virtually pure, and we came along and chucked out a whole pile of man-made objects, so it's pretty shameful. As an astronaut, it's a slightly bigger problem for me because it's actually dangerous.
A collision with a 1 millimeter pellet is the equivalent of a bowling ball fired at 100 kilometers an hour. For debris of 1 centimeters, it's 1,000 times greater. Let's say a large car traveling at 130 kilometers an hour. That means for your 1 centimeter, your satellite has a pretty rough time.
We've built highly sophisticated objects at a technical level. A satellite is a very sophisticated object at the pinnacle of what human intelligence can produce. And yet, when we made them, we didn't think that one fine day they would escape us and no longer obey us to the point of becoming dangerous.
Voilà une belle fable, j'allais dire. Enfin, une fable.
There's an interesting fable. I say fable, but the necessity of associating all technology with responsible reflection is a reality.
Une réflexion responsable.
Yes, indeed. Responsible reflection. Of course, I desire that we, the people of space, should have this reflection with regards to the sky and the stars. But also, and perhaps above all, with regards to the Earth and the people it supports, because we are all concerned in our towns and countryside. Space debris is a problem because if we do nothing and it proliferates as it has done, we will no longer be able to send satellites to use in space. You hear people saying, well, what's the point anyway? The point is that there are lots of things we could no longer do. No more weather forecasts, no more communication systems, no more GPS, so then people say, well, I'll just buy a map. But things like maritime and air transport are solely based on satellites. So you would suddenly have a truly critical situation on Earth. Millions and millions of pieces of information are exchanged around the world every day, every second, passing through space. Portable telephones, GPS, internet, but also television, bank withdrawals, stock prices, climate change data, as well as information concerning fishing, agriculture, prevention of natural catastrophes, and of course, military defense. We have all become totally dependent on space.
This sort of dependency also makes us fragile. Could it even become a form of slavery? Perhaps not, but in any case, are we not prisoners of all that? In the face of this, we should always avoid panicking, of course. Panic is certainly not a good advisor. But we can't go back in time. It's the same with technology as it is with mechanics. We worked out how to do it, so we can't just ignore it. On the other hand, we can always think of the future.
The problem isn't too serious at the moment, but in 30 years' time it will be extremely serious and it will be too late. There's a parallel with climate change. In the same way, people say, yes, but it's all right for now, it's not too serious. Maybe it's not, but we know that if we do nothing in 30 years, it will be a huge problem and it will be too late. But before it's too late, can we start by asking space to sort the problem out itself? Because, believe it or not, it possesses an incredible capacity for self-cleaning.
All objects in low orbit follow a spiral path which gradually brings them closer to the Earth until they end up re-entering the atmosphere.
Slowed down by the atmosphere, this low-altitude debris burns itself out during re-entry, but only partially.
We estimate that about 20% of the object's mass survives re-entry and collides with the Earth's surface. Objects are frequently re-entering. We estimate that there are about 2 catalogued objects, that is to say the size of a fist, which re-enter every day, and 2 large objects, for example, a satellite or a whole stage, which re-enter every week.
So no, the number of re-entries is not sufficient to rid space of this debris. Even more so because it's only the objects in low orbit, close to the Earth, which come back to us. Like this titanium tank. Like all the debris which threatens the Earth after having threatened space. But since 80% of the Earth is covered by oceans, the chances of an object from space hitting a human being are very slim. 1.5 million times less than of being struck by lightning. But the risk is there. And it is difficult to know precisely where this debris will land.
Today, we're not able to be precise enough to evacuate a zone. We're not yet at that level of precision.
And that poses a problem because imagine the eve of a re-entry. And there's a magnificent trail across the sky over Paris. A nice big object re-entering which we know is flying over Paris. No one's going to evacuate Paris saying, it'll be Paris, give or take once or twice around the Earth. So there's this sword of Damocles element which is extremely difficult.
Here's part of a rocket in low orbit, on its way back to Earth. Where will it end up landing? And if on its way it happened to come across the International Space Station? The priority in the debris problematic is to protect the lives of the astronauts. And for that, we've had to come up with short-term solutions. Because when I'm up there, I might have to deal with emergency situations, notably in the event of debris colliding with the shell of the ISS.
Earlier this morning, Chris Cassidy had noted an object that was floating past the station near the Station Progress 52 cargo ship.
We have repair kits like suction cups, a sort of special resin-like glue, and we could actually have to repair the shell of the space station. It hasn't happened yet, we've been lucky. We haven't had a hole in the outer shell, which the crew has been obliged to repair. But we're ready, we've been trained, and we have the equipment on board. And then, of course, the ISS sections, particularly those at the front, are reinforced, using the same system as a bulletproof vest. A bulletproof vest for a station under orbital threat. In Toulouse, at the Centre National d'Études Spatiales, the CNES, researchers consider ways of protecting the ISS. These 2 engineers are analysing an impact test carried out in the laboratory.
What is this test for?
This one is the first sheet of a multi-wall system. It's there to stop part of the debris.
This impact was caused by a pellet of only 1 millimeter, fired at a velocity similar to those found in space, 10 kilometers per second.
So if we double them up like this, that gives you the first sheet, the second sheet, and the third sheet. The particle goes through the first 2 and are usually stopped by the third, but here you can see that unfortunately, once again, one has gone through, and that's where the designers need to find the right parameters to make the system as efficient as possible.
But there is an imperative. The station mustn't be weighed down. That would push the fuel costs too high.
We can choose the materials for each sheet, we can choose their thickness and the distance between them, but all the same, we have to accept that we're faced with a compromise, because the greater the mass we use, the more the structure is penalized. The greater the distance, the more bulky the design, so it comes down to finding the best compromise.
This armor plating works very well for objects up to about 1 centimeter or 2. Beyond that, the force is too great for it to be effective.
But the most catastrophic situation would be to come into contact with debris during an extravehicular outing, when I'm in a spacesuit and suspended in the void. In this case, we're outside, so there's no question of armor plating. We're the ones who are there, so if there's the slightest debris, we're completely exposed. But globally speaking, the chances are very, very slim, so it's a risk we're prepared to take.
Generally, when astronauts are doing extravehicular operations, whenever possible, they place themselves behind an object which protects them from being hit.
I'll just watch that tether when I go back in.
But you don't always have that possibility. You may be obliged to move to unprotected places. In that case, well, being an astronaut is a dangerous occupation.
And what happens when debris can't be stopped by armor plating? Sometimes, nothing. That's what happened on the 24th of March, 2012. The NASA engineers told me about that day. There was a piece of debris too long to be slowed down by the station's protection, but too small to be precisely tracked.
I don't see anything. Which is the good news.
The timing of the notification to the flight control team of a possible conjunction came at a point that precluded planning for an avoid maneuver to steer clear of the object, the size of which has not yet been conclusively determined, even though the trajectory operations officer here in Mission Control has characterized the object as small.
The most problematic objects are those whose orbits are the least well known. Because the less well-known an object's orbit, the greater precautions which need to be taken when you come across it. So typically, the most worrying objects are the small ones.
On this occasion, it was impossible to modify the orbit of the station because no one could tell if it needed to be raised or lowered. The only remaining solution in these cases is the Soyuz. The next step is to go and join the Soyuz, which is the vessel which brought us to the station.
So the prudent thing to do was to shelter the crew, just to be absolutely sure that all steps had been taken to protect the crew.
The stress of waiting begins.
Flight controllers standing by here in Mission Control. Just 30 seconds to go until time of closest approach.
1 second.
The astronauts know that in the very, very unlikely case, and we're talking about 1 chance in 10,000, of a serious collision with the station, they just have to press the red button and they'll be deorbited and come back to Earth.
Nothing. Looks like that's it. Okay, very good.
The danger had passed, but the engineers were still worried. They knew where this debris had come from. It was born one day in 2009, causing the mobilization of the international community in the face of space pollution. Allow me to introduce you to its mother, Cosmos 2251, a Russian satellite dead since 1995. And its father, Iridium 33, a private American satellite in the prime of life and operational. In other words, maneuvering.
Iridium was part of a large constellation of maneuvering satellites, and therefore, in theory, we had the possibility of foreseeing the risk of a collision.
Up until then, a lot of people were saying, it's pointless trying to avoid the risk of a collision. The odds are minimal. Mathematically, they may be minimal, but mathematics is one thing and reality another.
And the 10th of February 2009,
It was a bit of a shock.
It's like with an aircraft collision. You say to yourself, there's so much room, how on earth can they actually bump into each other? And yet it happened.
We're precisely in the situation of having two satellites, two large objects coming into collision, and creating thousands of pieces of debris which are responsible for at least 30% of the evasive maneuvers which we undertake. And it's interesting because it was completely avoidable.
When they were asked, "But didn't you notice there was the risk of a collision?" they replied, "Well, yes, we noticed, but we have 99 satellites. If we went about reacting every time there was a risk of a collision, we'd do nothing else. So we just crossed our fingers." And that was when the international community realized that there was something seriously wrong.
The debris from the collision spread out around the globe. 3,000 new objects in space which horrified the international community and which pushed it to undertake certain medium-term solutions. Because there is no longer any question of ignoring the slightest risk of a collision. And since Iridium-33 was American, it was the United States who took things in hand, or more precisely their military, because they are at the forefront of space surveillance. Debris was their new public enemy number one, and the wanted posters took the form of American-style TV ads.
Sir, debris heading towards our comm satellite. Impact may cut off communications with ground forces.
Launch avoidance maneuver. "20 kilometers in closing."
Collision averted, sir. All objects are accounted for.
Good job.
Learn more at airforce.com.
It was a powerful wake-up call for America. And they started to say, not only do we need collision risk management for military satellites, we need it for all American satellites. And then someone went even one better and said we need it for all operational satellites which we're capable of helping.
Thanks to its radar network, the American Army set about cataloguing all visible debris, then putting in place an automated system which every day announces potentially risky rapprochements for all the world's satellites, whether they belong to private operators or national space agencies.
Correlation assessment. Space correlates this event. Copy that, sir.
That's the good news. The bad news is that consequently, we're submerged under tens of thousands of collision alerts all the time.
Paradoxically, it's the small operators with limited means who find themselves inundated with messages. They can't afford to react every time there's a dangerous rapprochement warning because they would end up doing nothing else. They didn't have a satellite built just so it could avoid debris.
Things needed to be improved. In France, we enhanced the American system. We customized it in such a way that it fulfills our own needs and protects our own satellites. At the head of the chain are our radars. We have 5 of them. This one, the Grave radar, which is fixed, and the SATAM radars, which are mobile. These are the principal tools used by the military at Cosmos, near to Lyon. A surveillance center for space objects.
Is the zone well covered?
Yes.
There's always a minimum of satellites in triangulation in a zone.
The military at Cosmos used the debris catalogue created by the Americans. But they complete and fine-tune this data using the French radars. This information is passed on to a partner. The Kaiser service, set up by the CNES 2 years ago. The only service of its kind in the world. This is where collision alerts are handled. Everything is automated.
Kaiser service, can I help you?
There is an alert for the satellite SMOS.
There's an alert for SMOS.
Shall I take a look?
Yes, please.
Today there's a collision alert for SMOS, a CNES satellite which measures ground humidity and ocean salinity. With SMOS, as with others, the Kaiser service helps about 20 satellite operators by doing the detection work for them.
The idea is to offer these services to operators who, if it weren't available, would prefer not to know and to do nothing. It's a system, a team, a service which handles collision risk for the operator. That is to say, it gathers and analyzes messages concerning it.
So, as a threat gradually intensifies, we can call upon supplementary radars with few additional calculations in order to narrow down the orbit.
I might ask for some SATAM measurements.
Yep.
That way we can narrow down the orbit of the secondary.
The secondary is the debris. Its trajectory needs to be better defined using the SATAM radars. The military comes into play.
Captain Collier?
Hello, Kaiser here.
Hello?
We have an alert for the satellite SMOS.
Yeah?
It's an object that has been clearly seen by the Grav, so you should be able to pick it up with the SATAMs too.
What's the rapprochement date?
The 15th at 1428 TU.
In 3 days, right. Could you give me the identity of the secondary object, please? 38039.
Will the SATAM radars manage to pick up the debris and define its orbit more precisely than the Americans were able to? Yes, they've done it.
Captain, here's the SATAM readout.
Thank you, Sergeant.
The threat has been confirmed. The debris' orbit has been narrowed down. In light blue is the orbit calculated by the Americans. In pink, the one calculated by the CNES, thanks to Cosmos.
The danger is still very much present. I think we'll have to convince them to lower it. That'll be less complicated.
Yes, I agree.
In reality, we don't predict, will there be a collision, yes or no? We look at the chances of there being a collision, and if the risk is greater than, say, 1 in 10,000, we maneuver the satellite into a less dangerous zone.
And this is where it all happens, in the SMOS satellite control room.
Okay, I'll be able to send the command. And you've managed to capture the signal? It's coming through now. And we're good. Perfect.
SMOS was brought down about 100 meters. Tomorrow it might be another satellite. And for the future, the European community is considering opening this service up to all operators who would like it.
This service needs to be provided to operators free of charge, which would mean they would have no reason not to use it because it would cost them nothing. And at the end of the day, it's in their interest to protect their satellites.
The age of Sputniks has passed. The satellites of the future will need to take into account the reality of space debris. That means a radical change in how satellites are conceived so that we are not obliged to avoid them when they are no longer in use. I firmly believe that that is where the long-term future lies, in the evolution of mentalities. And you can take my word for it, it's starting to happen. There is an initiative at the heart of the ESA called Clean Space, which is doing just that, which looks at the whole life cycle of a space mission from an environmental point of view. Personally, I love working with them, and I try to be a spokesman for this initiative because I think it's important. Set up in 2012, Clean Space is a department of the ESA based near to Amsterdam. A department dedicated to debris and satellites of the future. This is where they try to put in place, technically speaking, solutions for having the rules adhered to. Because there are rules for good international conduct. One of them is passivation. Passivate to avoid this. To passivate means emptying the fuel from components at the end of their life, like with this redundant fuel tank.
What we're seeing here is a venting of remaining cryogenic components inside the external fuel tank.
The propellant is turned into microscopic ice particles which rapidly evaporate when heated by the sun's rays. This is an essential measure since 35% of debris is due to explosions caused by fuel. Technical solutions exist, but Louisa, the head of this department, tirelessly pushes engineers to improve them. Draining the fuel from a satellite at the end of a mission is possible, but it's more complicated for batteries, which need to be discharged, or they too can end up exploding.
The battery from the power source, such as the solar array. And there's different methods on which we can use to do this. We can actually disconnect physically the solar array through some sort of pyro actuator. This stops the power going into the PCDU. Hence, we leave the PCDU on, we turn on all the equipment, and the battery gets drained. This is one option. Another option...
But the problem is that this disconnection apparatus could be triggered spontaneously, terminating the mission of a satellite costing several tens of millions of euros.
Power on the battery will actually dissipate, let's say. An alternative is to upload a software patch inside in the PCDU, which is a computer, and this would just basically tell the battery to never charge. But this isn't something that we can say will last indefinitely either, because it's a software patch, and through radiation around Earth's environment, there may be some sort of a flip. The battery will then continue charging, and then we're back to square one. Some form of passivation device on board.
There is a problem today of which Louisa is well aware. Operators who observe the rules for electrical passivation are few and far between.
It's very expensive to put up a satellite, and if you have one of these mechanisms on board which can accidentally fire, then you've lost your mission because you have no battery. So at the moment, from passivation purposes, this is quite a simple solution. But it's not something that project managers or anybody, a customer, will want to implement in their own mission.
I can understand why people do not put it on board. I'm still worried, how do we solve it? Because the software patch seems to be the easiest, but you are telling us that it's not forever. And the other one is dangerous.
So Louisa continues to work with her engineers to improve solutions, find others, and push operators to build clean satellites capable of respecting the essential rules of passivation.
New satellites must respect the rules of conduct which exist. There can be no special dispensations by saying, I'm a small company, I generate capital, or I create employment. Sorry, but no, we need to be serious and apply the rules.
Another rule of good conduct: no space apparatus is allowed to stay in space more than 25 years after the end of its mission. Many satellites are placed in high orbit, at more than 35,000 kilometers from Earth. When their life is over, they should be moved up higher, to graveyard orbits where they cause no more hindrance. Other satellites are in low orbit, at an altitude of between 160 and 2,000 kilometers. Those ones should come back to Earth.
Satellites need to have enough propellant in them to allow for maneuvers, so that they can come back down where we want them to, typically in the ocean. We call that controlled re-entry.
And controlled re-entries take place in the immense South Pacific. According to experts, the pollution thereby generated is negligible. This one too ended its days in the South Pacific, the ATV which helped us avoid debris by towing the station. There were a total of 5 ATVs. They were all brought back home to Earth at the end of their missions.
It generally takes about a day. The ATV leaves the station, and we progressively lower its orbit so it approaches the atmosphere. As of a certain moment, it becomes passive because the motors were left running. By the time the motors cut out, the ATV has slowed down sufficiently to fall naturally on its own.
Wow.
And the ATV appears in the sky above our heads, burning up due to the friction with the atmosphere. It ends up splashing down right in the middle of the South Pacific. Today, ATV production has been discontinued.
The last re-entry was particularly moving. All the teams were in the control center.
Oh, wow.
If you have a chance to look out of the window, because the view is spectacular.
Spectacular.
Spectacular. Whoa! Peter, tell me if we need to...
We're in front of our screens and we start to see the solar panels disappearing. Then the telemetry, which we receive from the ATV, starts to appear, disappear, appear, disappear, and then definitely disappear. And at that point, yes, we're sad.
But it's not in every operator's interest to perform this end-of-life maneuver. Because in order to do so, you have to save enough fuel. However, just imagine that a satellite has been programmed for a 5-year mission, for example.
You've finished your 5 years and your satellite is still working. What would you tend to do? Prolong its life. So you prolong it until the moment it dies, and then you can no longer maneuver it. There's often this perverse effect that we use it too much, and then we're unable to perform the end-of-life maneuver.
I refuse to accept that one day we may no longer be able to go into space. So these international good conduct rules should perhaps not only be applied, but turned into laws from which none are exempt. For the moment, only France has taken this step. And even if the rules were applied to the letter, that might still not be enough, because the amount of debris is such that from one collision to the next, it self-perpetuates.
When I make public appearances and I speak about space matters, the most common reaction is, "You've dirtied the sky. You've turned the sky into a garbage can." That's something I hear regularly. A garbage can. And I like to react by saying, if only. Because the garbage can is an extremely elaborate instrument for dealing with cultural debris. The garbage can can't be much more than a couple of centuries old. And it's essential that we do in space what we have done on Earth. That is to say, invent space garbage cans.
To deal with the very long term, a lot of dustbin projects are being studied. One solution would be to attach to the dead satellite a deorbiting kit capable of pushing it towards Earth re-entry. Another is to invent a robotic arm to grab the object and bring it down. Here's the same principle with a net. Or a sail to slow the object down so that it ends up rejoining the atmosphere. Recent studies are conclusive. 5 to 10 pieces of debris need to be removed each year if we are to stabilize their population. On paper, it looks simple enough. In practice, it's far more complex.
One difficulty is that debris is non-cooperative. That's to say, it doesn't tell you where it is, because it doesn't emit. It doesn't respond to radar. So you need to find a way of detecting it. It often moves on its own axis, and isn't designed to be grabbed, because it was launched before we thought of that.
No, we didn't think about debris when Envisat was built. This European satellite was intended for Earth surveillance. An 8-ton monster, as long as a bus, which broke down on the space highway in 2012. And it's this colossus which was chosen by the ESA to be brought back to Earth.
We said, let's try and come up with a mission to show the world that we can do it. It would represent an important technical step forward, so let's show that it's feasible.
But before sending a breakdown vehicle to recuperate Envisat, you need to know how it will react. That's what they tried to work out at the ESA laboratory in Amsterdam. These little caps are put under air pressure. This base is a glass mirror, one of the smoothest surfaces known. Mirror plus air equals 0 friction, or almost. A condition similar to that found in weightlessness, which allows us to better understand the random movement of a space object like Envisat, represented here by a model.
When a satellite is moving through space, there is no friction, so it will keep moving forever. If this was on Earth and I touched this like this, nothing would happen. But in space, if I touch it like a feather and I miss, it's starting rotating. So now what do? I have to try completely again. It's very difficult.
The model of Envisat is tracked by cameras which note each point on its trajectory. These points are then studied to reveal a constant, which would allow a better understanding of how an out-of-control object behaves in weightlessness. There's no question of sending a breakdown vehicle before that.
To capture a tumbling target, like a spacecraft like this, has not been done before. Some attempts have been done in some not quite the same sort of context.
T-minus 10.
This attempt was made in 1992. Endeavour, the American space shuttle, set off on an incredible mission.
1. Booster ignition and liftoff of the maiden voyage of Endeavour on a satellite rescue mission.
Seven women and men sent into space to go and rescue a satellite.
Yeah, and that sounds good. We got...
But not just any satellite. Intelsat 603, designed to handle television transmission of the Barcelona Olympics. And up there was sport in store. First event, catching the satellite.
I do believe. Oh, good. Oh, nice. Oh, no. Back away. Uh-oh.
A first failure, which would be followed by a second. Impossible to manhandle the satellite. The laws of physics are too far removed from those on Earth. So the engineers decided to put 3 astronauts on the job. An extravehicular outing involving 3 men at once and lasting 8 hours and 29 minutes, something unheard of at the time.
Yes, that's true. I can get it. Okay. Wait. Let's do it. We got it. Houston, I think we got a satellite.
Intelsat 603 was repaired in situ. Bringing it back to Earth would have been a completely different matter. But the operation helped us to understand the challenges involved when manipulating an object in space.
Hey, that old boy didn't want to go, did he?
Today, the old satellite has become space debris. And yet it's impossible not to salute the prowess of this rescue. Impossible not to salute the immense creativity behind so many years of space conquest. Yesterday, the Moon. Tomorrow, Mars. I am proud of what we have done, and I want to be proud of what we do to clean up space. What I really want to say is that it's an environmental problem, in fact. It's not just a space problem concerning those involved in space. It's an environmental problem in the same way as climate warming and pollution are. The philosophy is the same. These are problems which need to be resolved today, because we won't be able to resolve them in the future, and the consequences will be dramatic. They're problems which people are reluctant to tackle because the future seems a long way off, and because the various nations who send things into space sometimes say, yeah, but that's not one of ours, it's not our fault, it's expensive, etc. But initiatives are appearing, so we have the tools. We just need to keep developing them and put more effort into resolving environmental problems, whether on Earth or in space. We will never be able to eliminate all space debris, but let's make a start. Perhaps taking inspiration from what I felt and contemplated around me. It's all a question of balance.